Welcome once again to my YouTube channel. So today we are going to look into measurements of specific heat capacity of solid and as well liquid. In our previous class, I explained specific heat capacity and the heat capacity, also the relationship between both of them. We also do the simple calculations. So today we are going to concentrate on how to determine this very specific heat capacity of this very solid as well as liquid. Now, to obtain the specific heat capacity, there are materials you require for the experiment, such as calorimeter. You need liquid, such as water. You still need the solid you want to take the specific heat capacity of. Now, we are going to use a solid ball to determine the specific heat capacity of a solid ball. So determination of specific heat capacity of a solid ball first we need to get the mass of the ball. We have this very ball. We measure the what? The mass of this very ball. If you get the measurement of the mass, we said ms is the mass of the solid ball. Mass of the solid ball. Okay? Then we are looking for the specific heat capacity of this very solid ball. We will have CS as the specific heat capacity. That's the specific heat capacity of the solid ball. CS is the specific heat capacity of the solid ball. Okay. Now we need to raise this very ball to a particular temperature. Maybe we tie it to a fixed point. We boil this in water to get a specific temperature. So we apply heat now to get a specific temperature here. Maybe as this boils, the temperature might get to 100 degrees Celsius. That's the temperature of the boiling water. That gives the temperature of the solid. So in that case, we have the temperature of the solid. Maybe we'll have it to be 100 degrees Celsius with respect to this very one now. So we have temperature of the solid. The temperature of the solid. Then after this very case, you now need to get empty calorimeter. You have the calorimeter with stirrer and the thermometer. Okay. Then at this point, you need to weigh this empty calorimeter. Okay. This is the empty calorimeter. The empty calorimeter. So you have to weigh it to get the mass of empty calorimeter. That's the mass of the calorimeter. Mass of the calorimeter. Now, the specific heat capacity of the calorimeter is already known. The specific heat capacity of calorimeter, the specific heat of calorimeter. Okay. Now again, you need to pour some amount of water into this very calorimeter. Now you have the calorimeter. You have the calorimeter. You pour water into it. So this is calorimeter containing water. Calorimeter plus water. So at this case now, you have to weigh the calorimeter with the water. So we have mass of calorimeter plus water. So we have this mass of calorimeter plus water. At least with this, it will now aid you to get the mass of the water because you've known the mass of the calorimeter. Now you've got the mass of calorimeter plus water. Now, if you remove the mass of calorimeter, what will now be left will be mass of water. So in that case, you can now say that mass of water is equal to mass of calorimeter plus water minus mass of the calorimeter. So you have mass of the calorimeter. So this gives what? The mass of the water in this very what? Container. Now, you need to know the temperature of this very water. Get the temperature of this very water. That's the work of this thermometer here. Okay? So the thermometer will measure the temperature of this calorimeter and the water because the water itself and the calorimeter, both of them are in contact. So in that case, the temperature of this very water, in this case, will be the same thing with the temperature of the calorimeter. Okay? So we will now say that this temperature of calorimeter and the water, okay? Now, this temperature of calorimeter and the water is the same thing as the temperature of calorimeter. Is also the same thing as temperature of the water. So I can say temperature of calorimeter is also equal to the temperature of the water. Okay? So that's the temperature of calorimeter plus water. Okay? While this is the mass of the water. Mass of the water. So at this very point now, we will need to transfer the solid. Okay? We need to transfer this very solid quickly into the calorimeter containing water. Okay? And you know the temperature of this very water is now less than the temperature of the solid. So when you quickly transfer that very solid into it, then we are going to have this. We're going to have this. You have the stirrer, you have the thermometer, then you have the solid. Okay? This is the solid ball. So in this very case, you need to get the mass of the mixture. Of course, the mass of the mixture will now contain the calorimeter, the water, and the solid. Okay? So at this point, we have the mixture. So the moment you transfer this very solid, the hot solid, you transfer it into maybe warm water or cold water, you will observe that the heat will now be transferred from the solid to the liquid and the calorimeter. So in that very case now, we need to get the temperature when this very liquid must have mixed well with the solid. By then the heat must have been exchanged. So the solid exchanges its heat with that of water and the calorimeter. So at that very mixture, we need to get the temperature of the mixture. So we now take theta m as the temperature of the mixture. The temperature of the mixture. The temperature of the mixture. Now, having got the temperature of the mixture, now we can do some calculations Observing the conservation of energy, where it is said that energy can never be lost or gained in an enclosed system. So when we now neglect the heat loss due to environment, we can now say that the heat transferred by this very solid block is equal to heat gained by the water, and that one gained by the calorimeter, provided there is no what? Heat loss. So by assumption, there is no what? Heat loss. So in that case, we obey the what? The conservation of energy. So for the conservation of energy in that very case, we say that the heat loss by the solid, okay, will now be equal to heat gained by the calorimeter. Okay, heat gained by the calorimeter plus heat gained by the water. So the heat lost by the solid is equal to heat gained by the calorimeter plus heat gained by water. And you remember that we have a formula for heat as the mass times specific heat capacity times temperature change. So if you remember this very formula, so we can now employ this formula in our solving. So in that very case, heat lost by the solid, heat lost by the solid, heat lost by the solid, which is equal to the mass of the solid, the specific heat capacity of the solid, then the temperature change of the solid. Now, you remember, the temperature of the solid initially is theta S, right? While the final temperature of it is theta M. Now, the temperature of that solid must have decreased from theta S to theta M. So if you now want to get the temperature change, it should now be what? The theta S minus the theta M. So this gives you the what? The temperature change. Now, we get the heat gained by the calorimeter. Now, heat gained by the calorimeter. We have the mass of the calorimeter. We have the specific heat capacity of the calorimeter. Then the temperature change of the calorimeter. You remember that the calorimeter, the temperature is mild, the temperature is not up to that of hot solid. But being that the hot solid has transferred its heat, the calorimeter and the water will absorb the heat, thereby increasing in its temperature. So in order to get the temperature difference of the calorimeter, now the temperature of the calorimeter has increased as a result of that hot solid. So in that very case, the temperature of the mixture minus the temperature of that calorimeter will give temperature difference. So here we have temperature of the mixture minus the temperature of the calorimeter, which is also equal to the temperature of calorimeter and the water mixture, you remember. So in that case, we have the heat capacity, the specific heat capacity of that very what? The heat being equal to this, right? Then again, we have the heat absorbed by the water. So the heat absorbed by the water will now be mass of the water. Of course, you know how we got the mass of the water. Mass of the water is the difference between mass of the calorimeter and the water minus mass of the calorimeter. So here we have mass of the water, we have the specific heat capacity of the water, okay? Then the temperature difference of the water is the same thing with the temperature difference of the calorimeter. So here we have theta M minus theta CW. So at this very case now, we've got all the required quantities. Now we say the heat loss by the solid is now equal to heat gained by the calorimeter plus heat gained by the water. So if we do the substitution, we are going to have mass of the solid, specific heat capacity of the solid, the temperature difference of the solid, which will now be equal to the heat capacity of the calorimeter, mass of the calorimeter, specific heat capacity of the calorimeter, the temperature difference of the calorimeter. Okay? Then plus the heat for the water now becomes the mass of the water, the specific heat capacity of the water, then the temperature difference of the water. Then the one we are looking for is the specific heat capacity of the solid. So we have to make it the subject of the formula. So if we make it the subject of the formula, then it's going to be the specific heat capacity of the solid equals, remember you now divide with the coefficient of this Cs, which will be Ms and this temperature difference. So we have the mass of the calorimeter, the specific heat capacity of the calorimeter, then the temperature difference of the calorimeter. Then plus, we have the mass of the water, we have the temperature of the water, then we have the specific heat capacity of the water and the temperature difference. Okay? All divided by the coefficient of that Cs. So we have the mass of the solid, then the temperature difference of the solid. And that gives a formula. So from the question, we have 40 kg of a metal at 80 degrees Celsius was placed in a 60 kg of water at 20 degrees Celsius in a calorimeter of mass 70 kg made of the same metal. If the final temperature of the mixture is 30 degrees Celsius, calculate the specific heat capacity of the metal, given that the specific heat capacity of water is 4,200 joule per kilogram per Kelvin. Now let's write down the given parameters. 40 kg of a metal at 80 degrees Celsius, which means the mass of the solid was given as 40 kg. Then at 80 degrees Celsius, that's the temperature of the solid, 80 degrees Celsius, was placed in a 60 kg of water at 20 degrees Celsius. So we have the mass of the water should be 60 kg at a temperature 20 degrees Celsius. So the temperature of the water is 20 degrees Celsius. In a calorimeter of mass 70 kg. So the mass of the calorimeter is 70 kg, right? Then because the water is seen in the calorimeter, so the temperature of calorimeter will be the same thing with the temperature of water. Okay? Now, if the final temperature of the mixture is 30 degrees Celsius, so the temperature of the mixture is 30 degrees Celsius, calculate the specific heat capacity of the metal. So the specific heat capacity of the metal, which is C of the metal, that's the solid, is what? Then, in this very case, you recall that energy is conserved here, which means the heat loss by a metal will now be equal to heat gained by the calorimeter and the water as well. So we have heat loss by the calorimeter by the solid will now be equal to heat gained. Okay? So who loses the heat? That's the what? The solid. Who gains the heat? Then the calorimeter gains heat. Water also gains what? Heat. Then the formula for specific heat capacity, which we derived heat, we have mass of the solid, specific heat capacity of the solid, then the temperature difference of the solid. Now, the initial temperature of the solid is 80 degrees Celsius, while the temperature of the mixture is 30 degrees Celsius, which means there is what? Decrease in temperature of the solid from theta S to theta M. So, the temperature of the solid minus the temperature of the mixture, okay, which will now be equal to heat gained by the calorimeter. So, we have the mass of the calorimeter, the specific heat capacity of the calorimeter, then the temperature difference of the calorimeter. Look at the calorimeter, its temperature initially was 20 degrees Celsius as that of water, okay? Then it now increases to 30 degrees, which is the temperature of the mixture, which means we are taking temperature of the mixture minus temperature of the calorimeter. Temperature of the mixture minus temperature of the calorimeter, okay? Then plus mass of the water, specific heat capacity of the water, then the temperature difference, which is the same thing with that of calorimeter. So at this point, we need to do the substitution. Mass of the solid is given as 40 kg. The specific heat capacity of the solid is the one we are looking for. The temperature difference, which will now be 80 minus 30, which will now be equal to mass of the calorimeter. Mass of the calorimeter is 70. The specific heat capacity of the calorimeter. Now listen, the specific heat capacity of the calorimeter will be the same thing with the specific heat capacity of the solid. Let's see this. 40 kg of a metal at 80 degrees Celsius was placed in a 60 kg of water at 20 degrees Celsius in a calorimeter of mass 70 kg made of the same metal. Now, I want you to take a reference of this, made of the same metal, which means the calorimeter and the metal, both of them have the same specific heat capacity because they are made from the same source. So in that very case, we have the specific heat capacity of calorimeter, which will now be equal to the specific heat capacity of the solid because both are made of the same material. So we have the temperature difference, which is 30. Here we have 30 minus, we have the temperature of the calorimeter, which is 20. Then plus mass of the water, we have mass of the water to be 60 kg times specific heat capacity of the water was given as 4,200. So 4,200. Then times the temperature difference. The temperature difference is the same with that of water. So we have this, that of calorimeter and the water are the same. So at this point, we simplify. So here is 40 times specific heat capacity of the solid. 80 minus 30 will give 50. Then equal to 70 times specific heat capacity of solid times temperature difference. 30 minus 20 will give 10, right? Then plus we have 60 times 420, 4,002 times 30 minus 20 is 10. So we multiply 40 times 50 now. 40 times 50. Then here we have 2,000 specific heat capacity of solid. Then 70 times 10, we have 700 specific heat capacity of solid plus 60 times 4,200 times 10. So here we have 252,000. Okay. Now we do the subject formula in order to get DC of S. So here we have 2,000 specific heat capacity of solid. Then when it crosses equality sign, it becomes minus 700 specific heat capacity of solid equal to 252, okay, 000. So we subtract this 2,000 minus 700. We are going to get 1,003 C of S, which will now be equal to 25,20000. Now divide both sides by 1003. If you do that, divided by 1003, then we're going to have 1938.46. Specific heat capacity is measured in joule per kilogram per Kelvin. That gives the answer to the question. Okay, so if what we did was able to impress someone out there, please do subscribe, share, and turn on notification for others to learn as well.